I think that this AGC 48, it took place on Sunday or Saturday, and at the same time there was Google Kickstart, and I had a quite difficult choice between views on YouTube and solving interesting problems. So after all, I decided, as you might know, solving Google Kickstart, because, well, problems from Atcoder I can upsolve later as well. Let's test this thing. Yeah, I just have another window open when I can draw, and I just capture part of the window. I don't know if that will be perfect or not. In particular, my letters are ugly. I could just type it. Maybe that's better. Okay. Well, we can choose white font. Not that it's important. What's up, chat? If you're watching on YouTube, you need to go to Twitch for live chat. How to change font size? I will not bother with that today. Also, we have some noise today. Sorry about that. What's up? I had a chill day today. Good evening to you. Why you have ABP and uBlock at the same time? I don't remember. It didn't block something like, I think, code forces. This thing on the right. Oh, actually, it doesn't block it. Maybe because it's off. I'm annoyed, for example, with this rectangle in code forces, because when you refresh the page, you want to click something, but then this loads after half a second. It was a bit different earlier. I remember that I had a reason to have both. Anyway, why is this? Why did I mess up F? Yeah, here you go. Okay, let's start. Hello, resume boy. Atcoder smaller than S. How do I want to mark the fact that I'm solving the problem? Can I just take it in a circle or underscore? This is work in progress, just an idea I had today. So let's do this. Given is a string. Swap to adjacent characters. Find the minimum number of operations needed to make string lexicographically greater than Atcoder. That's some weak samples. If you want to be lexicographically greater than this string, then the first character can be B+, then it works. Or there can be some prefix equal to Atcoder, and then some big character like D. So this will work as well. If, let's think, I can iterate over what prefix I want to get to be equal to Atcoder. The problem is not done at the very beginning if the first character is A. Also, okay, then what if the second character is, let's say, B? Then with one operation I can make it good. Okay, what if this is AA? Is it enough to find the first non-A and say that we will move it like that? Any counterexample to this? If it's just A's, then that's impossible, unless it's a very short string. They are all hard problems today? Yes. Atcoder or Grand Contest is harder than Codeforces Division 1. But AAT, AAAZ. If it's something like this, then I think that the best we can do is, okay, we can move this to the second position, and that's also good. But I still think that we will just take the first non-A. I can just implement it. Oh no. Oh no. No, I've just killed my drawing. Okay, never mind then. I might do it later again. My drawing, I opened that window from terminal and I've just killed it. I'm stupid. And it isn't saved. Oh, there were test cases. No. Yes. Actually, let's say that this is an array, and in a moment I cast it to a string. Can I do it like this? Yep, I can. Now, I want this to be greater than Atcoder. If this then prints 0, let's say I just return the answer. Otherwise, if you see a non-A, push it to the left as far as you need that. Do I want to do it one by one or just make some ifs? Either I will push to the very first position, so possible answer is I, or if it's greater than t, or maybe what if it's exactly t? I don't think exactly t is enough. Yep. If s of I is greater than t, return I minus 1, else return I. And if it was all a's, what do I return in that case? Minus 1. Accepted. I didn't like the problem. I'm already guessing that it's too easy compared to other problems. It should be worth like 200 points, though. Okay, maybe fine. Atcoder doesn't really use at all programming problems. It's all about thinking, and that's too much thinking. Like here, is there some programming there or not? Give me a moment. Isn't that why Atcoder is appreciated? Atcoder is appreciated because it has some amazing problems. I don't think it's good that 90% or up to 100% of problems are of this style. It should be a mix, where majority of problems are of this style, you know, at least in my opinion. Perfect contest doesn't consist of problems of one type. This question becomes more difficult with brute force compared to the smart observation here. But how do you do it with brute force? The question is how much time should we think as a beginner? Read. My general advice is somewhere in FAQ. Read about it there. Okay. I'm back with this thing. Okay, so this is done. And now we're doing B. You can tell me later on Discord how I should modify this problem list thing. For brute force track Unix solution, I can do that. Results, all submissions. Problem A. How do I do that? Of user. It's still very short. Well, I guess this is the number of operations. No, not that. As is Q minus P. I think here we just say that we will move one index to some new position, because answer can only be a difference of two values. It's a strange while loop. So for every p up to 6, find the next greater letter so that you could put it here. If the we assume that prefix is equal. This solution I think should work for any string, not just string Atcoder. My solution works just for Atcoder. So his solution, if the prefix is XYZ and the prefix is arbitrary, for every position, he says, if this prefix is exactly that from the very beginning, and now I want to get something greater than h, I just look for the next greater character. Yeah, that's you know, my solution isn't easier. I wouldn't say that this is brute force. Oh, well, it is just something better because more general. So now let's do problem B. I think I already know a solution for B. I saw a spoiler in Facebook conversation with my friends. In this problem, we consider string with 2 types of brackets. I'm not reading this because I think I know what is good bracket sequence. Okay. Need to find a sequence of brackets of length n, and on every position I have information what's my score for this position if I put round bracket or square bracket there. This could be just a single sequence of values. So I first could put everything as round bracket, and then it's that there is some cost of swapping round into square. As I said, I was spoiled this. Apparently there is a very nice condition for when a sequence of 2 types of brackets is good. Because if I don't get to decide if something is opening or closing bracket, then this is a bad situation. But this kind of situation cannot happen in my problem because I'm the one deciding about opening versus closing. So there are some obvious conditions. I can say that every bracket is opening, or yeah, every bracket is opening, let's say. And now what are conditions for is this a good sequence? Of course, I can change the type of bracket from opening to closing. This is a good sequence because I can change it to, for example, open, close, open, close, open, close. Or those could be closes as well. Now prefix doesn't matter. Something like this will be for sure wrong. And whatever there is here, this is already bad. If there was odd number of brackets of one type, and now there is something of the other type, it's bad. So is that enough? Can I just say, oh, no, it's very wrong to say, because it's just enough that I will do something correct here, and then I will close this bracket like this. Why is stream only in 1080p? You can switch to YouTube for watching in different quality. So this must be even for sure. This is even. So if this is if this is position 0, then this matching position must be odd. So maybe, for example, 7. Yeah, and I know that the condition for a sequence to be good is that the number of round brackets on even and odd positions is the same. What about this? I don't know a proof, so maybe I will try to understand it. Let's say that if I get the very first thing, let's say it's opening, and now for the same type, if it will be on even position as well, it will be of type open. Odd position will be close. Is that good? So let's use some numbers: 0, 1, 2, 3, 4, 5, so on. If this is something, and now let's say that the next round is here because it's odd position. No, if it was here, I would say this is still opening one. There was this stuff here. Oh. So this means the start of some kind of sequence. Now this has good parity, so it will close this guy. Then this one must be opening. Now this one must be opening, and so on. If everything here was of even length, then it means that it created some closed part, and I can say that this would then close. I will need to look at the tutorial to understand exactly the proof. But I can believe it. And given that I believe it, that on even positions and odd positions there must be the same number of round and square brackets, is the problem easy? Let's think. When we have two sequences and for every position you choose between two values, let's first assume that everything what I take from the first of the first type. Oh, I need to answer that. I must do something in a few minutes. Okay, so this is some difference, and now depending on parity of position, something else will happen. What will happen? So for every position, what about this? I choose bracket of better type, and now maybe parity is bad. Will I fix parity by just a single switch? Let's say that n is 6. If I do something like this, this is bad. And also this should be bad. Those two are bad situations. You're very close, bro. You can do it. Thank you, Coding Jim. That's very motivating. I can iterate over the number of round brackets, no, the number of square brackets. If this, then even pushback diff. Even contains possibilities for me for every even position, every even index I, what I gain from switching from one type to the other. Then I will say that possible score is base, but also iterate over the number of the second type, and every time, I'm not sure what to put here, every time just switch one thing, so take one even and one odd. This is not really update of answer, update of base. Do I minimize or maximize? Maximize. This was a bit chaotic because there's just stuff going on in the apartment. Correct. In a moment I will do some summary of solution for you. What does editorial say? I need to mute for a moment, sorry. So, summary of solution, but first I need to read it. The official editorial with some proof. It is necessary that these positions can be decomposed into k over 2 pairs. Parties of this differ. Okay, so they use the fact that in this big sequence, the fact that two positions are paired with each other, it means that something between them must be a good bracket sequence, so this is even. So those two things, this and this, they must have the different parity. Yeah, and it turns out that this is sufficient. This follows from the fact that if there exists X that satisfies the condition, we can construct a good parenthesis sequence as follows. Sort the elements. Choose adjacent elements with different parities. Oh, and remove them. Okay, this kind of proof. Fine. Cool. Then I started by saying everything is round. And then I said, okay, what about this? I can have two square brackets. Which two do I want to take? There are brackets of two types, positions of two types, even and odd. There are those, and there are those. If I want one square pair, then I need to choose the best yellow one and the best blue one. So let's say that the best of yellows is here. So I change this to square, and the best of blues is here. For now, I don't care if this is opening or closing, because I already proved that if I take one of even parity and one of odd parity, everything is fine. And indeed, such a sequence, the one I produced here, I drew for you, it can be correctly matched. Like this. So I sorted differences to know what is the best blue and the best yellow switch. And I kept switching, and then I next best blue and yellow I switched to square, and so on and so on. So let's cross this out. And we will move to C. Such problems seem easy only after knowing the solution. I fully agree. I didn't participate in Codeforces 677. You might notice that I participate only in Division 1 contest in Codeforces. Same with Atcoder, basically any platform. But there are people on YouTube who cover solutions for Division 2. For example, David. How is it his channel called? Algorithms Fred. You can watch him. Now we will move to problem C. I will update the link. I forgot to do it for C. For problem B. There are L squares lining up horizontally in a row, numbered from left to right. There are N penguins. They are on distinct squares because there are strict inequalities here. You can do the following operations a number of times. Choose one penguin and slide it to left or right. It's 2, 3, 7, and we slide 2 to right. Wait, I thought that... Oh, we slide this penguin from position 3 to the right, then he will slide all the way to 6. If they are here, and we decide to slide this one to the right, he will go like that, and he will stop here. That will be his new position. The new configuration will be 1, 2, and 3. Your objective is to put penguin I on square BI for every I. Determine whether it's achievable. And you know, this kind of problem, it is very Atcoder-ish, and it's not about algorithms and programming mainly. It's about sitting with pen and paper and analyzing this process for a long time. Sometimes it turns out that there is some beautiful observation. Sometimes. Let's play around with this. I don't think I want to do it with a drawing, do I? What can I do here? Oh, I can move them around. So yeah, we can do it on a drawing. Let's say it's like this, and they are numbered. 1, 2, 3, 4, 5. Okay, I will save the initial positions. 1, 3, 6, 7, 8. This is the sequence A. No, you don't see it partially, sorry. Yeah, and let's play around. 2 can move to the left or to the right, but this will... It seems that this is bad for some reason. Okay, 3 can... that's interesting feature. 3 can move to the left, and this might be useful. Always after a move, something gets merged together. If 4 a moment ago was here, maybe I can just grab an object. No, I cannot. Is it true that the number of gaps can only decrease? Yes, it's true. Also, everything can only get closer together. If the first position in the initial sequence and in the final sequence, whatever that is, if they are the same, that it means this value cannot move. Oh wait, it can. There is no okay, let's assume that at the very beginning of the sequence, at the very end of the sequence, there is a penguin. Or like we will put it at position 0 and L+1. So I assume that this is the start and this is the end. Let's say so. Yeah, let's say that this didn't exist. This is the sequence from the very beginning. If it isn't the case, then I just add penguin 0 and L+1. Can we do something smart? How can I put, let's say, guy number 4 from some position to, let's say, 2 positions on the left, but there is nobody there right now? Can 4 ever get here? I don't think so. I think that 4 can only get here or more to the left. But if there is some guy and he wants to get here, let's say a bit further away, let's say he wants to get right here. But there are already some people there, Y, Z, A, B, and so on. He can get there if and only if now he could. We can move A there, then Z, Y, X. So if penguin number X, I might need to write it down. If penguin P1, if penguin P is on position J, then I can move penguin number, let's say P minus 3 on position J minus 3. By moving everybody, like P minus 1 will go to J minus 1, P minus 2 there, and so on and so on. So now all of them, they would move like that. A here, Z there, Y here. Then X, it gets here. Just remember that it's not that I know the operations. I need to analyze what operations are possible. Then should I use sliding to the left in order to allow somebody to slide right and reach some destination? I don't think so. If A is here and I want some B to slide there, then B isn't better, like better right border for anybody. Because if any X wants to get somewhere, then if B is here and A is here, it doesn't matter. X doesn't care about it. Now, does it hurt? If we have this situation, the one on the second drawing, does it hurt that now I put everybody to the right? B, A, Z, Y, X. I would say it doesn't hurt. It's not that Y, Z, A moved too far to the right. So whatever later I want to do with them, I can. Maybe we will get an algorithmic problem after all. There are some positions of penguins. A1, A2, A3, A4, A5, and so on. Now, if I want to slide this guy to the right, I can get him to position this one minus 1, A2 minus 1, so this one minus 1, or this one minus 2, or this one minus 3, or this one minus 4. Maybe it helps to visualize that, I'm not sure about it, but there are some current positions. Instead of saying that everything is by 1 to the right, let's modify the statement just a little bit. So if your initial sequence is, I don't know, 2, 4, 5, 9, instead of this, I want to work with 2, 3, 3, 6. And now with this new sequence, I say that value can be changed to neighboring value. And that's it. So, yes, AI changed into AI minus 1, minus I, minus equal I. This is what I did. After I did this, now every operation is a bit easier to understand. I will not need to deal with plus minus 1. And now, for example, when I see that, well, 3 wants to become, there is some sequence I have already, and there is 3 here, and 3 wants to become 7. In this suffix, I will just binary search value 7. And I will say that everything here changes into 7s. Can I do stuff in any order? There is initial sequence, and there is some final sequence that I want to achieve. The fact that this is currently 3 and it wants to change into 7 at the end, and there is some 7 here, it means that all of that shifts into 7. So this suffix will need to be changed into this, not using anything from the prefix. Need to take a look at samples. Okay, after, it's not enough samples. I have penguins on positions 0, 3, 4, 6, 10, and 12. And I want to get at the end 0, 1, 5, 6, 11, 12. Let's do my modification. So from every number, decrease it by I. The first sequence is this. Nope, something's wrong. Minus 3, then minus 4, 12 minus 5. 2, 3, minus 3, 3, minus 4, 7, minus 5, 7. Okay, forget about that. Can I just say that the new sequence, after my modification, here just I change value to neighboring value. So maybe I can achieve in the same order just some blocks. If at the beginning I have value 0, 2, 3, 6, 7, maybe I can get any sequence with zeros, then 2s, maybe 0 of them, then 3s, 6s, 7s. 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 6s, If I can copy value to neighboring value, then I don't see why not. Order does matter, right? Like given this and final that. Yeah, order of operations matters indeed. That would be a very simple solution, and this aha moment is very nice. And that's all what Atcoder is about. Okay, let's implement. Do we minimum number of operations needed? Okay, it's not that simple. Given one sequence and operation that copy number to neighboring number, what's the number of operations we need to get this at the end? Well, if I have 0 here and 0 there, and I want 0 in the second position, then I say that this is one operation. Then, well, 3 is needed here, 7 is needed here. I see 3 operations. But that's for sure an easy example, because maybe something will disappear. What about 0, 6, 6, 7, 7, 7? I need to copy 7 here and 7 there, but earlier I need to copy 6 here, 6 here. I can as well say that it's copied like that. 6 here. So every value, it has some interval initially from L to R. This is also some interval, and I need to propagate. If I need to shift interval from here indices L to R to some new thing on the left from lowercase l, lowercase r, then I think the number of operations I need is this minus that. So in that case, 3 was on this position, no, 6 was on this position, and at the end I want it to get up to that one. How far 6 needs to travel? So I would say that here 6 will travel those around those three positions. It will override them. This will be 6, 6, 6, and then 7 will do its job. Yep. That's like saying that penguins have width 0 rather than 1. Exactly. That's what I'm doing. I just wanted to say that they don't stop 1 before something, because that's very annoying. I need to understand, instead of saying that everything is a block merged with each other, if they differ by 1, I want to say if they differ by 0. Yeah, you can imagine that this happens. There is that, positions for penguins, and if there is one penguin here of width 1, and there is one here of width 2, and one here of width 1, each of them has width 1, because they are numbered 1 to 3. Now imagine that each of them collapses. So this one collapses into a single point. Then the new drawing will look like this. This gap of size 1, here penguin being a single point, then this is the gap, then penguin 2 and penguin 3, and then the final gap, this one. And yeah, I just say that they are points between gaps. So for every penguin, if I just care about its new position, that's the number of empty blocks on the left, and that's exactly ai minus I. From your position, I subtract how many penguins on the left, including yourself, collapsed to width 0. That's just interpretation, but yeah, the solution is here. And let's try to code it. And N and L. I will twice do something. Make a for loop for that, or a function. Vector initially just with value 0. This. Let's say that there is one more element at the end. This is equal to L plus 1. Reading wrong. Yep, reading wrong. 0 to 2, 3, 6, 7. Is that right? Just like my drawing. 0, 2, 2, 3, 6, 7. Oh yeah, I made the drawing here. 0, 0, 3, 7, 7. Yep. My program does exactly what I wanted it to do. Sometimes it's nice instead of, when you are not in a hurry, then it's quite nice to, from time to time, print what your program computed already for the sample test. Just, you know, for your convenience to know that, okay, that's done. I can now focus on the second part. Second part being, for every value in the new sequence, it must exist in the first sequence. That's the condition for whether the answer exists or not. So here we would need to create one, but I can only copy a value to a neighboring value. That's impossible. This value exists, this value exists, this value exists. Do I use a map or 2 pointers? Let's use a map. I can later rewrite to 2 pointers as a challenge. What do I need? I need actually an interval. Those are positions in the first sequence. Position of a of I dot first if I is 0, or if this is a new value, then this, and this always override. Or whatever, it's fine. For every value, I want a pair to represent interval. What are positions of this guy? But actually, I think I need the same for the second one. So let's put this here and just return it. This is now a map. V. Zero is from position 0 to 0, 2 is on those positions, and so on. This value is on positions from 3 to 3. Cool. In the second sequence, for every object, in the second one, the value is pp.first. If this value doesn't exist in the first one, print -1. Otherwise, we count operations, and I believe that can overflow an int. And just do the formula. If first I'm from position 5 forward, and in the second one I'm from position 3 forward, then I need 2 operations to move to the left. So it's if I move from 5 to 3, that's 2 operations. If I move from 5 to 3, or this can be just pp.first. And similar thing with right ends. If I'm up to 7, and now I want to be up to 9. Value, value, value. Wait, this is dot second dot. Let's make it just nicer to read, though a little bit slower. 3 and 13. And all of this for sure can be done with 2 pointers, because we have 2 sorted sequences and we do something with them. We want to find intervals of equal values. Nice. I like the problem. How is that people that have been doing CP for less time are better than you? Is that, yes, it's talent, luck, knowing math. I don't know why you would expect in any sport or science does everybody perform the same? If you grab 100 people, do you expect any two to be equal after 1 year of training? Quick look at editorial to see if it's the same. Numbers of consecutive squares without penguins. So we take sequence of differences. Okay, it's I see what this is. I see the difference with my solution, but also some similarity. Doesn't matter too much. I believe that now we will move to difficult problems. What's the scores? Okay, D is 900, but I saw in standings that D doesn't have a lot of accepted submissions. I will just see that in the standings. I don't care about spoilering myself a difficulty. Yeah, this E and F are basically unsolvable for me, and D is maybe solvable. So far so good. I'm happy with my speed of solving C. B I don't know, because I knew the solution already, or the main observation. This done. Now doing the considering zero with penguins was ORZ. It was useful, but I did that before. I used this technique because maybe a few years ago I used something like that in a problem. Also, answering to the question about me being worse than William or BenQ, yes, they are training harder than me, for sure. I never trained like 4 months every day, anything like that, no. Okay, I will read the statement to just start thinking about it, then grab something from the kitchen and move back. In first left turn, he removes 1 or more stones from the leftmost pile. With he removes 1 or more stones from the rightmost pile. Okay, let me quickly analyze what happens for n equal to 2. Is that just comparison? If I have some pile and he has some pile, there are 2 of us, I don't want to remove my whole pile because then he can remove the whole pile and I lost. So everybody will take a single stone. Then just bigger pile wins if n equal to 2. Then we just compare if AI is greater than, no, if A1 greater than A2. And that's it. If yes, I win. I meaning first player. What happens for n equal to 3? When I have a choice, do I remove the whole thing? I can remove it if then second is greater than third. Otherwise, I don't want to remove everything. If I remove a lot, then my opponent will remove the whole thing. So here I will remove 1 element, most likely. Then what about my opponent? My opponent will remove everything if and only if this is smaller than that, smaller or equal. Otherwise, he doesn't want to like remove this. It seems that it's like who first gets to exactly this level. So also, I would say that it's comparison between A1 and A3, but something else happens if they both are smaller than A2. What we really compare is how much I'm bigger than the middle stack. If I'm already smaller than middle stack, then it doesn't matter what is my height. Okay, for a moment it's enough. As I said, I'm grabbing something from the kitchen. Be right back, 1 minute. Yep, I'm back. Do we write brute force in this problem? With brute force, I can see, depending on middle stack, like whether I'm right here with my observation, that it's comparison of first and third, unless one of them is smaller than the middle one. Like if two of them are smaller than the middle one, then the first player wins, or something like that. Yeah, exactly. Then, yeah, we go to 4 elements. Chat, do you want to make drawings and analyze what is possible for n is 4 or for n being 4 or 5, or just general case? Or do we implement a brute force and just try to understand from the output what's the ifs, what I need to implement in the full solution? So what do I recommend? Hard to say. Those two paths are viable now, and with more experience you can better guess which one is good. It also depends a little bit on a problem. If I expect a problem to be very good, it shouldn't be about printing stuff with brute force and analyzing the output. If I know for sure that this problem is awesome, the problem setter created something nice, and it's not just about implementing brute force and noticing a pattern, then I will not implement a brute force. But judging from my experience with problems from past a few years, for example in code forces, it's so common that it's just about doing brute force. I think it's very common in Division 1B problems that it's a 2-player game, and it helps to do a brute force and see a pattern. You can explain while writing code? I don't know what to explain. While writing code, I would just do the brute force. Hello, Jape. Well, let's try the brute force. It's quite easy. That's also argument to do a brute force. If a size is 1, I win. Otherwise, done. Consider if the first value is 5, I can take from 1 to 5 elements, or stones, from the first element. Create a new sequence, reverse it, from the last element decrease by the number of taken stones, If it's 0 pop back, the sequence is now shorter, and check if the new situation is losing for the first player to move at the next moment. First, let's check on sample test if this is correct or not. First, second, cool. And now let's print what happens if there are only two, if n is equal to 2. If it's a winning situation, print, let's say hash, else a dot. That should be quite visible. I expect something to happen like below and above the diagonal, exactly. So here it's just about one element being bigger than the other one. Now what if I add a middle element? Middle element is 3. If both elements are smaller than 5, the first and third, then the first person wins. I can do this as well. Let's make this faster. No, I preferred dots. Let's make this faster. Add memoization. If memo count of a By the way, you can join my Discord server. Link is in the description, also right now in the Twitch chat. Discord, here you go. If you enjoyed the stream, then you will also enjoy being in the Discord server. You can discuss my video streams with me, or also just hang out, talk about random shit. If this return is this. Yep, now it's faster. So what about 3,3? What will we see? This is easy to understand, just nothing changed. If two middle elements are the same, then it's as if they didn't exist. But what if one is greater than the other? Huh. Then it seems that the value of this small element, f3, doesn't matter. Let's make this a bit more automatic. If the second value is between 1 and 4, and the third value is 5, then the output doesn't change. Only when it becomes 5, then it's as if the two middle elements didn't exist. For 6, well, then we have a situation when third is smaller than 5. This is quite symmetrical, right? Yep. Okay. Now we need to move to 3, like n equal to 5. I also from this understand n equal to 4. I can hardcode stuff, compute exactly what is the condition. Here apparently a minus b, we compare that with the bigger of two middle values or something like that. Unless they are equal to each other. That's a special condition. Size and size and length are the same. Okay. I put here 5 and 5, and then we have this. Oh. This jumped by a lot, right? Oh, not by a lot, just that it shifts completely. Up to 5, it's very regular. Where is it? Up to 4, it's very regular, because the diagonal starts here. This is similar. And now this starts there because it's just extension of the main diagonal with this square of 5 by 5. And then from 6 forward, it's similar, but like that. I'm not having fun right now. If second and fourth are 5, this is small, in the middle between them, it does not matter. From 5 it's something special, just like if it was just, I think, 3 elements, right? No, like that. Yeah, exactly. This is the same. Then what for 6? Damn it. What do I think about IOI problems? They are cool. IOI in past few years produces very high quality problems. It's cool how they choose problems, and like the fact that it's not mainly about heavy knowledge. There are a lot of steps, and some of them are very, I would say they are legendary already, like Aliens from 2016 or 2012. How can you come up with DP with so many steps? With so many like subtasks where you can improve it from like n to 5th power to linear times logarithm. Okay. Is it true here that a value between two bigger values doesn't affect the answer? What about this? A, B, 5, 5, 5. Whoa. What does this mean? If B is at least 5, then first player will win. What am I doing? Two, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for this, one needs a value of 14 first. For 15, only for 15 he wins. 15, 1, 5, 5, 5 is a winning for first player, otherwise it isn't. Maybe we care about some kind of increasing and decreasing parts. Will this change at all? So this, for B up to 4, does it change? No. What about putting 9, 7 here? It might matter. I thought that B equal to 1, 2, 3, 4 will all be the same answer here. It isn't true. And that's a very irregular shape. It will be solved using DP, I guess, but finding that minimum number under which first left can win is a hassle. Okay, maybe it's time to get back to thinking about it instead of just trying to guess from this. But is it always true that starting from some value A, I think it wasn't true here. Yeah. Okay, it is true. Okay, it is true. For every sequence, if we ignore the first element, there is some first element, minimal value of first element, such that we will win. Okay, if A was small, like smaller than 100, then the number of possible states would be very, very small, like because we choose interval of the sequence and the first and last value can change. For AIs up to 100, it's polynomial solution. I mean, polynomial of n and AI. I don't know of a linear time solution, so I think finding an explicit pattern might be hard. Okay, that's fair. If generally, because n is up to 100, it suggests that finding a specific pattern is hard. If there is first value and there is last value, is it fair to say that the only two possible moves are to take one stone or to take the whole pile? I think so. But we can check that. I can check that with brute force here, but yeah, it seems obvious. I could modify this a little bit and then check for random vectors if the answer didn't change. If I take a single element and my opponent takes a single element, then do I want to take the whole thing? Yes. In particular, if the sequence is 5-1, I take a single element, then my opponent takes one, then I take everything. But maybe if I take a single element, so this is the initial situation, then for 3, then he takes a single element, then is it fair to say that I always follow with a single element? No. Imagine this. Here I can win because I make this. No, actually I immediately remove everything. Okay, what about that? What about this? If I take the whole 5, then he will lose. No, he will win. So then it's like that. He cannot remove the whole thing, so it's this. Now it's my turn. And I should remove the whole 4. Because then whatever he does here, I repeat over there. And so I have a winning move, so yeah, I win. So it isn't true that after he decreases by 1, I can also decrease by 1. Because if instead of winning I will decrease this to 3, 3, 3, he will remove then the whole 3, and now whatever I do with first element he can copy here. So I would lose. So we only decrease by 1 or remove the whole thing, but it's hard to say, like, I cannot say that after this then blah blah. There are only sum of a square total states, right? Right. Yes, I agree. I wanted to say that the number of states is this, n square times ai square, but even better estimation, or just exact number for number of states, is sum over ai square. Because it's sum over ai times this. Are we sure that we are not overthinking this problem? I don't know the solution, so I don't know. Maybe the solution is very easy. But, link doesn't work. Sorry, I need to update this. Now it will work. It's quite small, yes. Maybe I should imagine this as some two-dimensional grid, where row means yeah. So let's say that row will mean where I am. All the stones I set in one huge row, but intervals of them, they represent one pile. So always from some position I could take the next one or up to the end of the interval. So if I imagine some matrix of Boolean values if this state is winning or not, maybe that helps. We could both move by one. There are a lot of possibilities because for a long time I can take one, he can take one, and so on, back and forth. When does it stop? Okay, I have an idea. There will be only n square interesting moments. Not moments, stones. And if two stones aren't interesting, I can skip both. Okay. If, for example, the sequence is 10, 2, 1, 2. I think I can take one stone. No, that's stupid. Let's decrease those values. This can be represented as well as a sequence of stones. For every stone I write down what's the pile ID. Now it's a two-player game. We start here. I can move by one to the right or just to the next beginning of the sequence. So this is the beginning, or beginning of interval. This is beginning, and this is beginning. Or maybe it's better to think about split points. So now let's say stars are split points. And initially I start between, yeah, like that. Four, 2, okay, that's one interpretation of the input. Let's say that this is also a star and this is a star. can jump by 1, or so I can get here, or I can jump to the next star. And if the sequences are long, then for a long time I will get -1 from both ends. But when should any player stop doing +1 or the -1? When something changed. So when we look at the rest of intervals, the remaining intervals in the middle, something like the sum of them, or maybe sum of values in some prefix or suffix, is equal to the current value. It's something like that. Some equality must happen. Maybe this way I will eventually get like 2 to nth exponential solution, but it's still something, because values AI are so huge. Basically, it means that something changes only when this number is equal to the sum of remaining values, or maybe the difference of them. Each number will be taken with plus or minus. Yes, I'm assuming that we do take one or take all, Gupta. I want to check something. Let's try n being at least 3. I want to check what is the possible value of a, let's say the first guy, so that something would change. Maybe it's always equal to prefix or suffix or of something. That would be very nice. Or maybe, like, sometimes I think I take a difference, or like maximum. Let's see. V of n. While not true, win of v plus plus, not a plus plus, a doesn't exist, plus plus v of 0. For this, I needed 15 in the first position. That's 7 plus 8. Here I needed 10. Or here I needed 9. What is 9? What kind of random value is this? 7. 19. 14. This is suffix plus 1? No. It's very often suffix plus 1. This is the exception. What about this? Maybe for n up to 4, always the first value is equal to, let's print after decreasing by 1. So this is the biggest first value, such that this is a losing situation. And 11 is 6 plus 5, 8 plus 5, 5, 7, 11. Okay. This is 2. That's not good. Maybe suffix minus prefix. Where was my 5? 13 minus 9 is 4. Okay. What about suffix minus prefix? Then 9 minus 3. 11 minus 2. 11 minus 6. 14, 22. 18, 27. 13 minus 8. 4, 8. 11 minus 10. Okay, let's check that. This is V, not A. For 15. Okay, let's try to find the smallest bad n. I really hope that what I say is true. True up to 6. Apparently 11 is that biggest value for which I'm losing, and now it isn't true that it's equal to some suffix minus prefix. By the way, that would mean that for that boundary condition, some suffix is equal to some prefix. 10, 12, 17, 17 minus 4 minus 9. 18 minus 9. Would it help if I allowed this? Up to from 12, 17, 18. Oh, it doesn't help here at all. I thought it does. Because for every previous sequence, I claim that some prefix is equal to some suffix. If you do 2 pointers on any of those, you will find such a situation. 18 is equal to 6 plus 6 plus 5, that's 17, 21, 21. Yeah, here 21, and I bet that this will be 21 up to some moment. 5, 6, 8, 13 and 13. Yeah, this is our first counter example. Okay, I'm taking hints from the chat. If you have some ideas, some insights from the solution, from the editorial, you can help me a little bit. Maybe I need to like maintain a linear function for every maybe something like this. If I have a sequence, focus on this middle part, and then depending on the last value, if this last value is B, then what's the minimal A so that I would win, or that greatest A that I lose as the first player. Maybe this is pairwise linear function with just small number of pieces. Maybe it's exponential number of pieces. If this is true, then can I solve it? For the something of length 1 it is true. So here I want to denote f of b is, let's say, mean A such that I win. Minimum value of A such that I win, if B is the last element. For single element, that's true. There are like 2 pieces. It's true that this is piecewise linear function with just 2 parts. The function will look like a constant thing and then linear, more or less. or in other words, the thing I printed a long time ago. Okay, we don't see it now. It's regular. A human will see a pattern, so a machine can also do that. Okay. If I figured that for this thing, depending on this value, the A to win, this is linear, then now can I do the same for what? Okay, now let's focus on this. Depending on this A, what's the minimal A to win? So I know this, and I also know what happens if I get down to this interval. Maybe let's make something bigger. I know things about this interval, and I know things about this interval. If I get down to this interval, I'm able to tell in constant or logarithmic time who will win. Now consider this. So we have this bigger interval, and I want to say, depending on the last value, what happens. There are some possibilities. The first guy can just take the whole first number, and then we immediately go to this interval. It would be nice for this interval to know both sides. Also, what happens if the rightmost guy moves first. If I have that, then I'm good. I can just copy that function here. Checking if others are alive or not. I don't think on Tuesdays there are a lot of alive people in the chat. Okay, the alternative is that A decreases by 1, and then B decreases by 1, and one of them can decide to eventually stop and to take the whole number. So it's kind of who of them is closer to winning. Okay. Oh, this is easy. It's some easy DP? Wait a second. I need to know when I'm looking at this interval of 5 values. The first guy or the last guy, one of them will remove a number. He will do it only if in the remaining interval he can win. So when going down to this interval, I would like to know for this interval what's the minimum value. I don't even need piecewise linear functions. dp of LR of 0. Minimum remaining value of A of L such that first player wins. And dp of LR1, minimum remaining value of A of R such that second player wins if he starts now. Now, when I want to compute dp of LR, I need to look at something quite simple. Let's say that my interval is this. The first value is 3. For now, they don't matter. But I'm the first player. I want to check if removing this value right now would be good enough. So then I check if this interval, if the last value isn't changed, yeah, if the last value isn't changed. I need to survive subtracting by 1 enough times so that this value would be smaller than this. If I see that, let's say that this is L, this is R. Let's say that dp of L plus 1 R1 is equal 5. So if this value is at least 5, when we get down to this interval, then my opponent will win. Let's say that this is 7. And I have some value here, a question mark, an x. I need to survive decreasing x twice. My opponent then decreases 7 twice, down to 5. And then I can grab the whole x. The question is whether I will survive that or not. For how many moves I need to decrease by 1 to then be able to take the whole thing. For my opponent, it's quite similar. He considers removing the whole value. So it's kind of like removing the whole value is a winning move, but only starting from some moment. Let's say that x is 9. Here I have something, a value y, and dp of L plus LR minus 1, 0 is 4. Then it means that I need to decrease y by 1 so many times that this value is 4. So I need to do it like 5 times or 4 times, plus minus 1, doesn't matter. I need to survive decreasing y 5 times. And it's just about comparing how many times I need to do this to survive versus him. And that's it. Okay, anybody sees some issues here? If that's the case, then I overcomplicated so much. This is a relatively simple DP problem. I'm even curious that I'm thinking whether I should check the editorial now to see if that's correct. Yeah, so to compute now dp of LR0, I can, for example, binary search. No, don't. Okay, I will not. I think binary searching will be most convenient. Yeah. Okay, let's copy all of this. Let's also open it just in case I need it. I will not remove this because that's important. Test cases. Yes, test cases. I guess because otherwise tests would be just with answer true or false. and then with some heuristic maybe it's easy to guess and it's easy to pass a lot of tests, and if something fails then you try to binary search that test, like hack the tests more or less, hence the test cases. Why did I go with brute force? Oh, I remember. I didn't know what to do. I asked the chat and chat mainly said that I can go with brute force and patterns. Well, I should have assumed that Atcoder creates nice problems. I see that Rabinon asked some question about practicing for lead code. You can ask me that on Thursday. On Thursdays I'm doing coding interview streams. Right now I'm just doing my own thing, a very difficult, something quite difficult. I don't want to talk about coding interviews now. If you have trouble solving problems online on LeetCode, maybe grab a book, maybe read Cracking the Coding Interview. If L is equal R, that's some easy base case. But now, otherwise, I will do binary search. I think that's convenient to do. And I'm afraid that maybe I need a number as big as n times AI, like the sum of all AIs. What am I doing? This. I want this to be long. Okay. This is the first element. So instead of A of mid, I have maybe high is enough to do here A of mid, but I don't like it. In some way, I would need to denote that I need huge value here to make it. Yeah, I'm not sure. I prefer this. A mid is changed into mid. No, A of low. A of L is changed into mid. That's the meaning. I need to be careful not to mess up L and R with low and high. But if I mess up, I will get segmentation fault, I think. Atcoder creates good problems, so what about code forces? Code forces is fine on their own. I like code forces rounds recently. What did I say? That I need to say how many times I need to decrease by 1 first so that I could remove the whole number. So I need to take a look at this. A of R minus dp of L plus 1 R 1. This, for example, says that if that last value is at least 5, then the last guy will win. Then what if this is 7? If I move twice, then that will change to 5. Then I remove the whole number, he will win. I need to move 3 times. he answers 3 times as well, and then I'm good. I can take the whole value. Then I don't need binary search. Now what if this gets negative? I think it's safe to say that this is at least 1. No, I need this plus 2. Because if it's 7 and 5, I need to decrease 3 times. So I need to be at least 4. Let's say that if the first value is 1, I cannot decrease by 1 further. I need to take the whole element. After decreased by 1 twice, he decreased twice, so he's 5 instead of 7. Now I take the whole number, I will lose. Okay, now something similar, I guess. Was this problem that easy? Why did I say put? Okay. DP not declared. Something's wrong. Maybe it's not that easy. Here it's first indeed, then 0, 1. They say that the first value should be at least 3 to win. Okay, the last value should be at least 4 to win. That's correct. If this is at least 4, then you will win. Okay, and in the last one, 2, 1, 2. When we look at this, if this is at least 3, you will win. This is at least 2, you will win. Yes. 0, 1. You need to be at least 2, you need to be at least 3. Now finally here, in some way I computed that if I am at least 2, second should win. Let's analyze this 2, 1, 2. If I take the whole thing, then he will take 1 and he will win, because that's symmetrical situation. Then I need to take 1, then, oh, okay, then he can take the whole thing and it's symmetrical again. So what is wrong? Let's see how this is computed. I take a look at dp of 1 to 1. dp of 1 to 1 is 2. Because for this, if the second element is at least 2, then second guy will win if he starts. Okay, so I need to decrease that many times. Oh, I think I need binary search. So what I computed is how many steps I need to make to allow myself winning. This assumes that he will always respond with taking 1. But he has a choice of taking the whole value and then something else will happen. This thing needs to use dp of lr minus 1 as well. It's not that if it's my move now, then I will take 1 and then always my opponent will respond with 1 as well. No. This is why it's more complicated, so let's use binary search. Okay. So I say that AL is mid. So this is kind of my decrease, must decrease, how many times I must decrease. He must decrease. No. It will be something like this. Okay, how did I get this? If the last element is 7 and this is 5, I need to make 3 moves. Once, twice, and third time he will decrease to 4. Okay. Why did I have +2 here? Why not +1? Because this is how many times I must decrease. So like from 4 I would decrease 3 times to get 1. Good. By the way, if somebody has just joined, you can use !link on Atcoder to grab a link to the problem, read the statement yourself. Like I'm already solving this problem for 1 hour, so I will not once every 15 minutes get back to the statement and explain it. Sorry. Tuesday streams are quite boring if you don't know problems already. On Thursday I will have an easier stream in 2 days from now. I must decrease 3 times. Then he responds with those, and then I take the whole number and I win. How many times he must decrease? So let's call it I need full turns. The full turns of I do something, he responds. I do something, he responds. Now how many full turns he needs? Let's think. If the first value is 7, and if we realize that if it's 5 or more, then the first guy wins, then he wants to 1 full turn will change the first value to 6, second full turn to 5, then when third turn runs, it will change to 4, then I can snap. So for him just 2 full turns are enough. And in the third full turn he will already respond with attack, with taking the whole value. Now this is not AL, this is mid. If we both need 2 full turns, then I win. Then I am winning. And maybe lower value is enough. This can be overwritten multiple times, that's fine. I think that we are good now. And by the way, the main thing, you should learn from this, assuming that I didn't make a mistake, is how I do this thing with 7 and 5, with off by 1 errors. Like I just think about an example. And I'm instead of guessing, I'm trying to understand the formula from example, which sounds like guessing, but it isn't. How am I? I'm fine. I'm fine if I indeed solve this problem correctly. Then I will be happy. And it's already 2 hours and a half of a stream, so I don't have time for hard problems. Not that I would solve them anyway today. 5 people only solved E during a contest. Okay, this. Can I in some way reuse this code? I think it's quite different. Well, now AR becomes mid, and I want to understand what happens. What's the number of my full turns? And I can take the whole I think that we will have this, but I will think some more about this. Okay. I need full turns, so when I can kill, this depends on comparison of A of L and what happens after I take the whole number, and now it's his move. If I need full turns is smaller equal than this. Damn it. Overflow. Still an overflow. 85. I can submit or I can test. Do you guys want to see testing? Because we already have brute force. Or should I just submit? When will I play Among Us? I don't know. Among Us isn't any kind of priority for me. I played a lot for like 2 weeks, and now I didn't even play with my friends for what? 2 weeks? Yeah, I don't know. Sure, test it real quick, submit. Coding better than Among Us? Coding is my life and my job, so yes, it's more important. Let's grab this. Let's imagine that it's a contest and I don't want to get too many wrong answers. Need a generator. That's sad. If in Linux you want to learn what I'm doing right now, you can watch my stress testing video on YouTube. This is our counterexample, 1 for 1. For 1 for 1, I take this, my opponent takes this, and I take that, so I win. But my program prints second. This is 1 for 1. For this, I need at least 2, he needs at least 5. For this, I need at least 5, he needs at least 2. For 0, 2, I need at least 2. That shouldn't be true. For 1, that should be enough. Oh, that can be negative. For sure it's bad. For sure, okay. Should I maximize with 0? I think so. So how many full turns I need before I do that? So how much time I wait? Yeah. Then it's good I test it. Otherwise, getting wrong answer and that's just being blind with a test doesn't help. Okay, good. This is a better sign. Works for n up to 2 plus 6, that's 8. If this passes, I'm submitting. And I use binary search inside, so instead of n square, I have n squared times logarithm of value. This was just for my convenience for sure, because I'm just comparing some two values like this, maximized with 0. I can figure out a formula. The formula will depend just on those 4 values. AR, and just 3 values actually, AR and those 2 DPs. But I don't really want to figure out the exact result. Score of 0. So what happened? Runtime error. Because I have a brute force. I need to be more careful with this. I could do something like if def local, then this, and if. Then I could just submit this. Yeah, let's accept it. Let's just check if it will indeed work. And I need to be careful with this, or like put a warning to remove it. This should be accepted as well. Done. A, B, C, D. And it didn't take me that long. maybe, just maybe, I would solve ABCD during the contest. And then it wouldn't be a bad place. Still, to have a good place, I would also need to solve E, or instead of something, solve E. I usually go for high variation, and I try a hard problem and I skip something. You will see that in my past results in Atcoder or Code Forces. So then it's actually not likely that I would solve ABCD. At some moment I would skip to E or to F, and I would likely mess it up. Maybe I would aim for something like that, for example. Well, A was trivial, I would solve it first. Yep, D is done. Quick look at editorial. What is the minimum value of AI under which first left can win? Yep. I overcomplicated a lot. I don't know why it was so much. Somebody should have told me, hey, don't do brute force, don't try to see a pattern. That was stupid. It wasn't your fault. I asked you that. It was perfectly fine that somebody in the chat said that brute force. It's my fault not realizing that brute force is a stupid idea. E and F are still left. I will not do them today, but I will try next week, I think. So let's do this. So announcement, next week will be me trying to solve E and F, I think. Plus maybe the inclusion-exclusion problem from a few weeks ago. Did I have fun or was it frustrating? It wasn't frustrating at any point today. I wasn't stuck for like a very long time. When I thought that I'm starting to get stuck in this problem, I got the idea of DP. So I'm happy because for C, I got the idea myself, didn't look at the editorial, same for D. Basically, today I didn't need to look up anything in the editorial. That's good. Yeah, exactly. I didn't need to see the editorial. That's the important thing. I honestly absolved ABCD. Quick look here. No, thank you. It was exponential. Okay, thanks for info. That's just something we discussed earlier during some stream. The future hard problem streams, you can put that in Discord server. Okay, that's everything for today. I don't know. I learned math before learning programming. Thank you everybody for watching. See you on Thursday for coding interviews, and Saturday I will not be home on Saturday, but I think what I will do is I will pre-record participating in Code Forces round, maybe virtual participation of Steph Daska's round, the Dust Division 2 round, and I will just put that as premiere on YouTube on Saturday during normal stream time, so you can just watch and hang out with each other in the chat. I will be in the chat too. I just cannot stream on Saturday. Yep. If you have any questions about that or any suggestions, go to the Discord server. Have a good night, everybody. Bye bye. Thank you for watching. And okay, is anybody streaming competitive programming or something similar? Building an OnlyFans competitor? That's interesting. Recommended channels. There are no titles here. Okay, Linux kernel coding. Also, what do you think about this, the problem list drawing? Is it good, bad? Should it be more professional? Tourist has it just like there are 6 letters and he colors them. Once he solves something, it's green. I guess he just opens any text editor and then he can mark something and change color. If, for example, he has Microsoft Word on the side, just can grab part of the window. I opened something like Paint on the side and did a similar thing. Okay, I'm done with choosing. Story still in university? Yes, but I don't know what he's doing now. Masters, or maybe he's already done with masters. Okay, so again, good night. Have a nice ride.